Hi everyone, again welcome to this lecture. Today we will be continuing the discussion on TclTk that we started last time. This is I think like the third lecture on the TclTk. Let's see what we did last time. So we started like the first lecture with the basic understanding of the Tcl, how Tcl works, and how Tcl was invented and all those things. Then last week we started in earnest understanding the Tcl programming language. We started with the Tcl commands and how they are interpreted. As I said, Tcl commands essentially so there is no command syntax or actually like no grammar for Tcl. Essentially commands are nothing but words separated by white space. And then the way that the interpreter works is there is a built-in interpreter which divides the entire command into various words, and then it sends those words to a parser. The parser actually then finds out what is the real function, and that can recursively call the interpreter for further elaboration. But it's just a very simple thing basically. Again, I want to emphasize this because in the very first lecture we saw that actually we want a very lightweight scripting language, unlike C, C++, which are like much more heavy languages. And essentially, like once again, I want to emphasize that Tcl is used to for run applications and extending applications, run multiple applications, and also like extending applications. Today it has been a very prevalent use of Tcl across various tools that you will use later on in your career. There is not a single tool today that does not use Tcl. Also wanted to emphasize that Tcl is platform independent scripting language. So unlike any kind of shell or anything you take, and then they are dependent on the particular platform that you use, and there will be like small quirks associated with those platforms. There is a shell associated with Tcl, that is the wish that we saw in the very first lecture. I forgot to mention about that in the last one. So just remember that the wish was developed specifically for Tcl. And again, the Tcl was developed at UC Berkeley by Osterhout, who also wrote that book. And if you look at the other book that I mentioned, which is the Brent Welch, Brent is a student of Osterhout, and essentially he's probably one of the first persons who actually wrote programs in Tcl. So those two books are very good reads. So I would encourage you to look at those two books as main references. So coming back to Tcl commands, the Tcl command is as I mentioned, it's words separated by white space. The first word is a function, and all the others are arguments. Only functions apply meanings to the argument. As I said, Tcl itself does not have any kind of grammar, so the function really applies the meanings to the arguments. It's always it is single pass tokenizing and substitution. And then there are two main concepts that we introduced in the last lecture. One is what is called the variable interpolation or variable substitution. Just cut this and then say substitution. Variable substitution is essentially using these dollar sign. So whenever it sees the dollar, it substitutes that variable with the actual value. And then you also have the second one, which is second important concept, which is the command substitution. So I'm just saying in substitution. So the command substitution is using these two factors. Whenever we see that anything enclosed in a square brackets, essentially like that is the first one again is interpreted as command, and that is executed first, and then the result is actually fed into the remainder of the expression. Then there are two ways of preventing the word breaks. One is with the double quotes. So whatever is enclosed within double quotes, it's treated as one word. And then we also have this the curly braces, essentially, like that also prevents interpolation. So this also prevents the word breaks. So the difference between these two is that the quotes will still cause the interpolation of the variable or the commands essentially. So the command substitution and the word substitution are possible within the quotes, whereas if you put it in the curly braces, then it prevents all the interpolation as well. Then the last one is we saw the escape characters. Essentially, escape characters are for special characters. So if you escape them as even as a dollar, then that will not cause any interpolation. It will be printed as is. Again, I want to emphasize that TcL is a scripting language. Usually takes strings as the input and strings as the output. So it doesn't attach any kind of type to the data. The way that type is provided is through those functions that we will talk about more and more. So after this, we also looked at the TcL expressions as to what are the rules for the expressions. One rule that comes to my mind is this floating point versus fixed point. So whenever we write the fixed point expressions, the TcL also like considers the result as a fixed point, whereas the moment we start a floating point, it doesn't matter after that how many fixed points that we use, the TcL expression will return a floating point number. So this is something that you need to use it with caution. So I will advise you, and then I'll leave it at that. And then we also started looking at the TcL lists essentially. So lists are essentially like they are collection of objects essentially, and then we assign we can actually group those the elements in a list and separated by a white space. Essentially, like the list is simply a string with list elements separated by white space. We can use braces or quotes to group the words with white space into a single list element, which is very similar to what we saw here essentially. So we can use the curly braces to group elements and treat them as a single element inside a list. And then there are many commands associated with lists. A list command essentially like list will create a list, and then there are several of the other commands that we will see in this section in today's section that will actually work with the list and manipulate and process the list. So some of the commands we also saw in the last ones are lindex. The lindex essentially like with an argument list and a number I will return the ith element from the list, and the length list returns the number of elements inside that list. We also have range. I think you can guess what it is, and append. There are insert, which inserts exactly at where you want to insert. Append will actually insert at the end. And then L sort is another way to actually sort a list, and this can take multiple um, options. Essentially, like we can give like various switches called ASCII or integer or real, and then you can specify whether you want an increasing sort or decreasing sort, things like that. And then there are also like to concatenate uh, a list. Essentially, like we have um, concatenate multiple lists. We have concat command. We also have a join command for joining a new string into a list. And then split string is the other one, which is essentially the split command is basically to split on a particular string the list into two separate lists. So I think like these are the things that we talked about. Um, we will also like go through some examples later on. But I also wanted to actually talk about some of today's things. One is the commands and lists essentially. Um, so lists parse cleanly as commands. Each element becomes one word. But in order to create commands safely, we use the list command itself. That is the one that we saw here, just list. The reason for that is here there is one command. The command itself is set x init value, $init value. So this is essentially like what it is means is basically the init value is read when the button is invoked. Now this command is fine. We can also do this init value in quotes so that it actually like does the command substitution. But here the issue is if this init value is two different words separated by a blank space in between, then it fails because now this variable that it expects is actually a list essentially, or set x New York is not possible. This command fails because this is the x that it is setting this value to, and the init value is New York, which it cannot set it. So essentially like the command will fail here. Whereas if you say okay now set x and in quotes we give the init value, or sorry in curly braces we give the init value. Now what happens is if you have init value as one of the curly braces, then it fails because again like this is not a valid command because there is no escape character, nothing for the curly braces. So how do we specify the same thing where we want the command as set x to the init value, which is safe so that it covers any condition possible? So what we do is essentially like now we say command, here we specify the list and then we say the x as init value instead of the quotes or inside that the curly braces. So here it will work because if the init value is this curly brace, then it basically it automatically escapes that curly brace and essentially it gives you as set x as the escaped curly brace, which will work. So essentially using the list command is a very safe way to actually specify list files, specify lists. So we will see this more and more. Again, one thing to note is TcL, it's prone to a lot of errors, and you can make a lot of mistakes and you can make a lot of errors very easily, and then quickly you can actually get bogged down into your own errors and trying to debug those errors. So some of the safe practices when we say when I show it to you, I think you should actually heed and pretty much try to adopt these kind of safer practices, which will enable you to succeed in coding in TclTk. So now we come to the strings essentially. So we know that the string commands essentially are again there are many commands for string manipulation. Strings again strings are group of characters that we talked about in the previous lectures, and then string manipulation is one of the main thing basically, and string is the basic data item in TclTk, and as I also mentioned that the commands themselves or essentially like the whole commands are parsed as strings, which is essentially character separated by word space, and essentially like using that we can do like lot of things, and then the key thing to also understand is using strings we can do pattern matching, which I will talk about, and pattern matching is again one of the key elements in the TclTk, and it is slightly different than what we saw in Perl for that matter, and the two main concepts are, one is exact matching and glob matching. This is GLOB, globbing. So glob matching and exact matching. We will see like what is this glob style and then what that means. So the string manipulation command, so regex. So this is for the regular expression. There is also a format. There is a split string, reg sub, scan, and join. These are all the string manipulation commands. There is the basic command which is also a string, and the way to use is string followed by operation and then string value and then any other arguments. So string command, similar to the list command that we talked about, is the main command. Essentially like that's listed here. This is the string command, and then the string has the sub command which is this operation that can be compare, first, last, index, length, match, range, to upper, to lower, trim, trim left, and trim right. So we will see like some of the examples of how to use these commands. One quick note is all the indexes within the string start with 0. So if I say Seer Academy, so this is string value 0, the index 0, and I is also you can say end. Okay, so it starts with 0 and then end means the last character in this example, and notice that actually it's one word. So if I split it here, this is a string, this is another string, and for this string this is 0 and this is the end, for this string this is 0 and this is the end. So it actually goes like 0, 1, 2, 3. if you make it continuous, then it's actually 4, 5, 6, 7, 8, 9, 10. So the value index 10 is also same as index n. Okay. So now let's look at these commands. The string compare takes two more arguments, which is string 1 and string 2, and that returns 0 if they are equal, minus 1 if string 1 starts before string 2, or it returns 1. So just this compare has 3 return values. And then the first also takes two arguments, string 1 and string 2, and then that returns the index in string 2 of the first occurrence of string 1. If the string 1 does not exist as a part in string 2, then it returns -1 to indicate that the string 1 is not part. And then the same is last, essentially, which is the last occurrence of that particular um, string 1. Some of the other ones that are interesting are range. Range gives, basically it also takes two additional, actually like 3 additional arguments, one the string and then 2 numbers, and then it returns the characters between those 2 numbers as the range. And then the string match, actually that takes a pattern, and also after that it's a string, so it takes 2 more arguments, a pattern and a string, and then it returns 1 if the string matches the pattern, otherwise it returns 0. And here the string match command, this one uses the globe style matching. That means that you can use special characters and wildcards. We will actually see that in the further example. Then we can also like trim the string, essentially, which is it trims from both ends of the string, and then the character usually, like, I mean, it also has an optional characters that you can take, and that is the characters it will trim. And optionally, I mean, for as a default, the character is always white space, which is it trims the white space from both ends if there are any. And then the trim left and trim right does the same thing on the either side. The 2 upper and 2 lower is essentially to uppercase the string or the lowercase string. So now let's look at the key thing that I mentioned in the previous one, which is the globbing. So the globbing and regular expression, essentially, the globbing is a simple pattern language. So I want to emphasize these 4 things which you want to use in globbing style, which essentially, like, I mean, which you can really use those 4 styles. First one is the star. That means any sequence of characters. So if you want to match, say, Seer A star that matches Seer Academy in any kind of spelling, or just Seer A, that's fine. So anything that the star will specify that, basically. Then we have the question mark. Question mark matches 1 character at a time. So how many ever question mark you give, it matches that many characters. For example, if you say S question mark R Academy, then it won't match Sierra Academy because you have two characters in between, and it only matches one of them. So that will match SIR Academy, SAR Academy, SUR Academy, whichever way that you can spell, it will match. Now we can also have square brackets and some characters in the middle. This can be characters or a range of characters, and here it matches those specific characters, and it matches one character in that range. Again, you can have like multiple of these essentially to match more than one character, but every square bracket will match one character out of that set, the set that is specified here. And then we can also like backslash with C, which matches C even if it is all these special characters. So if you want to exactly match a star, you basically escape it as star. So that matches exactly that character. So I wanted to make a distinction between the globe style pattern matching and the globe command that we saw in the earlier ones. Oh, before that, here are some of the examples. So star.exe, that is specifically this globe style, which is this one, and then we can also have A through E star. That is, first character it matches A, B, C, D, E. After that, it can have any number of characters, and with the extension text. Here we can escape the question mark, which is basically, so it needs to have like question mark, then any number dot back is what is matched here. So it will be a good exercise if you can actually identify these kind of things later on in a TclTk program. Now the globe command is also like another common command. Please don't confuse it with the globing style matching. The globe command applies a globe pattern to file name. Essentially the globe actually returns the Unix file names in that particular directory. So here for each f, globe star.exe puts $f is a program. Basically it goes to your current directory and looks for any of the exes, and then it prints out this message for those programs. So the globe command returns the Unix files essentially, whereas globing style matching is used to match the particular characters. Now if you specify, like, I mean, so what is the alternative? So this is by using string match. Now if you say string exact, then this needs to have, it won't match these stars or all these square brackets, etc. So now a couple of more things about regular expressions. One is this period, that also matches any character. The caret matches the start of the string, dollar matches the end of the string, and then the backslash x is a single character escape, and then the square brackets essentially matches any set of characters. Tilde is not, and essentially you can use dash to indicate the range. So these are some of the things that you can use within the square brackets. So if you do square bracket tilde a e, then it won't match the set A through E, which is a range. for the first character. You can have anything like from F through Z or any numbers or anything like that. Okay. In the parentheses and the regular expression matches the regular expression, and here the star matches 0 or more preceding, the plus matches 1 or more of the preceding, and then the question mark matches 0 or 1 of the preceding, and then we can use this bar to divide alternatives. So here are some examples of the regular expressions. So here A through Z, lowercase a through Z, 0 to 9, and then underscore, and then when it is plus it is 1 or more. This is a valid TclTk identifier. So any kind of variable names are using this. Then here we say like TclTk or TK with parenthesis and then using the bar T, CL or K, so that matches to TclTk or TK. So here another in this regex command, it's regex TclTk. I mention TK WT. So this will return 1, which is a match, and then the W becomes TK, and then the T gets K essentially. So if you recall, the regex command actually it gives basically the regex followed by flags which are optional, and the pattern here, and then the string. And then the last two are the sub 1 and sub 2, which is essentially here what are the sub strings from this match that gets added to it. Okay, so now let's look at the reg sub command. So that so essentially, like I mean, so here it matches the TK here, so the W becomes the TK, which is what is matched here, and then the T gets the substring K, which is where the match happened. Now let's look at the reg sub command. Reg sub command again has switches. Here in this case, it's the no case is the switch, and then the pattern, which is essentially like here it is Perl, and then followed by string, and then we also have a sub spec essentially for this and a variable name. So here the no case Perl means match any case of Perl. So it returns 1, a match, because it matches this Perl, and then the mantra is the variable name that gets this I love tickle as the string, because once it matches this Perl, it replaces that Perl with tickle and then assigns that whole string to this new variable mantra. Okay. So now here is one example, one quick question essentially, like I'm in more case, where is A to Z star, escape question mark, and then you have where is Bob, and then we say basically like the subspec is who's, and then escape 1, and then put it in result. So how do we interpret this? Is essentially like so this is going to match where is some name, any name, followed by question mark. So here the string is where is Bob, so it matches, and so it returns 1 as a perfect match. Now you look at the parenthesis here. So whatever is within the parenthesis will get replaced, because this is termed as escape 1. So now basically the subspec calls for who is and then replaces with this here, and then that string is assigned to result. So the result gets who's Bob, because the Bob is the one that got matched, and then this is the parenthesis that's called as escape 1, and then that goes here. So I may give you like some more exercises to work on these concepts. I think these are quite important ones for general understanding of block style matching and plus regular expressions. Now the format command, essentially this is something that also like we talked about in this one. This does string formatting. So in how do we format a string? Essentially like we give the particular value, and then essentially like we use it in substitution to that particular thing. So again here we say basically it's format, and then this is what is known as the spec, and then these are all the various values. So this is value 1, and then you can have multiple values. So every occurrence of this various characters get replaced with those values. So here we say like %d, that means that it is a signed integer, and so 97 is an integer, and then that gets replaced here. You can have unsigned integers. We have O for unsigned octals, X for unsigned hexadecimal, C for mapping an integer to the ASCII character it represents, S is for a string, F is for floating point, and then E is using scientific notation, and then the G is in either the percentage f, which is the floating point, or the scientific notation, whichever is shorter, use that. So essentially, like pretty much it boils down to the format is has most of the printf capabilities. We can also use it to create complex command strings. Now the next one is scan. Scan is like scanf in C programming. So the scanf actually parses a string according to a format and assigns the values to the variables. So here let's assume that the string x has this information, which is SSN, and then we say basically like some number. So when we say scan, we scan this particular variable $x, and then we say a format which is SSN hash is %d, and then that is assigned to SSN. Now if you say like the social security number is $SSN, this SSN basically gets replaced with this number here from here, and then we can actually display that number. So again, for scan command, the syntax is scan string, which is the same as the $x here, and then the format, and then followed by variable. So here the format is %d, or this whole thing SSN %d, and then the variable is SSN. So that's how this assignment works. So now we come to another interesting topic, which is the control structures. Control structures are needed for controlling the various operations. This basically gives the program the real structure, or essentially the essence of the program is all in the control structure. We covered this for Perl. We talked about its data structures, and then we went into more control structures. Even this is very similar. The control structures are like C in TcL. So if you know C, it is very easy to write these control structures in TcL, or you'll understand it much better. They are just commands that take TcL scripts as arguments. Again, you should think again when we come to the TcL, there is no grammar, so everything is just a command, and then the command will take other TcL scripts as arguments for it. For example, there's a list reversal where we set the list B to reverse of list A. So how do we do this? So here we declare a variable called B, and then we say we set the I to the L length of A minus 1. Can anyone tell me, like, what does this do? So L length actually gives the length of the list essentially, and then we need to subtract 1 from it because the first element is 0. So if you have n numbers, the actual list indexes are 0 through n minus 1. So if there are n elements, it's actually each one is indexed 0 through n minus 1. So we subtract that 1 from that thing, and then now we just go through this while loop, which is one of the control structures. and then we say $I greater than or equal to 0, as long as the I is greater than 0, do this, which is L append B to L index A $I. So again, L index $I returns the character or the list element which is of I from the list $A. So now B becomes, or B0 becomes A end, and then we increment I plus 1, oh sorry, so increment I with -1, which is actually decrementing I. So here now the next element will be B1 because we do L append, will becomes A end -1 and so on. So now you can see that actually, like, I mean, it becomes a reverse, and finally this is the end will be A0, and that's when the program terminates. So it's a good program to do the reversal of list, but you can use this, so you can see that actually there is a control structure here which is the while. So for doing for controlling the commands or controlling the structures, or the control structure commands are essentially if, for, which, break, for each, while, eval, continue, and source. The source command is very commonly used. Essentially, it is to source a set of procedures or a new commands. So let's look at if else. So here we say the variable x, we set it to 2, and say that if it is less than 3, then put x is less than 3. If x is otherwise, it just has x greater than 3, x is 3 or more. So when you execute this program for x value of 2, now it will say this and it will exit. It won't execute this at all because it's already x is less than 3. And then this is the while example. We saw this list reversal essentially. Here the V is E, B, C, B, A after executing this program. This is the same thing that we saw before. Now we have for and for each. So for usually we say set I 0, then $I less than 10, increment I, and then puts dollar whatever essentially. And we can say like $I itself. And then for each actually uses a list as its main arguments, and it uses another variable in the middle, and this variable essentially is just taken through each of the values inside the list. So for each color, red, green, blue, puts I like color, so it basically puts I like red, I like green, I like blue. Three statements. Now there is another one which is the set A1 as A, A2 as B, A3, A26 as Z. Assume that everything in between is also set somehow. Now for each index, array names A puts A and then the index. So there are two things basically, like I mean in an array. So these are what is called array commands essentially. Array also, like I mean, we will go through these kind of commands, but in array as an data structure, the command is array, and then you have names and values. So the names actually return the indexes. all the indexes, and then the values return what it is set to. For example, these. So in this case, essentially, like when you say index array names A and then puts a $index, now we can see that this program will output A, B, and Z. So and then finally this command called switch. Essentially, this is very similar to the K statement that you may be familiar with. So here we see another example. So we put these counts as 0, and then for each name we have several names here, a list of names, and then we say switch, and based on the regex name, so it's basically this name, and then if it matches with Pete as the first character, essentially like this is the first one, and then this is the number, and then this is the main thing, and then we increment Pete count. And then if it needs Bob or Robert, then we'll increment the Bob count, and then default is increment other count. So now can you tell me, like, I mean, what this program will generate as the counts? So for the Pete count, it counts 1, 2, so this will be 2. For the Bob Robert, essentially it matches here 1, 2, and 3. So this is 3. And then finally, like, I mean, the default is increment other count. The other count is actually 1, 2, 3, 4, 5, 6. So it goes to the catch-all anyway. So now you have 6, 2, and 3. Okay, so let's look at some more rules on the control structures. So here we have x is 3, and then we say if x is greater than 2, and this is okay because it is evaluated only once. But if you say while x greater than 2 and then you're setting x to 3, this is just an infinite loop. Now here we have a set A as red, blue, green, the list of red, blue, green. Now say, like, we say for each $a, this is an okay syntax. But if you say, like, I mean, same thing with the red, blue, green, then this is not okay. Okay, this is essentially it basically just errors out because it just gets confused, as we know that for each has just 2 arguments, 1 and 2. So once it sees like more number of words, it basically comes out. And then for each array names A, this is a common EDN in TclTk. So now let's look at one small example, which is just a fun example for all the. I mean, so this is the control structure that we are all familiar with, and then very easy to understand too. So we'll look at this one, and then we'll look at some complicated examples in the next lecture. So here first of all, what is this? What does this program do? This program identifies person as either a child, a teen, or adult. How does it do? So it asks for a question, how old are you? And then it gets that that value. So it takes it from the standard in and assigns to this variable called age. Then it just examines that variable. So if age is greater than or equal to 0 and if age is less than or equal to 12, then it prints out as your child. If age is greater than or equal to 13 and age less than 19, then it turns out that age you are a teen. And then finally, if age is greater than 19, then it says that you are an adult. So a simple program. So how can you write with, say, switch statement? Number one, switch statement, and number two is what happens if the input age less than 0, and then how can you make it robust? So let's discuss this in the next lecture. So I want you to go and work on this one. Essentially, first of all, modify this program into using switches, this switch basically, which is essentially which we learned about it here, right here. And then the second thing is what happens in this program if you put age as less than 0. What is the program output? Try to find out. And then the last question is how can you make it robust, meaning how can you cover this condition if this errors out or it doesn't error out, how can you cover this condition, and that also you can use the switch command essentially. So let's pick it up from this point in the next lecture. Thank you all. You have a wonderful day. Thank you. Bye bye.